All right, Advanced Math A, here we go. We've got lesson 6.2.3, Systems and Multiple Representations. And we're not going to actually continue in our learning. What we're going to do is take a little pause here and make sure that you're kind of getting the deeper meanings of what we're doing. Not just how do you solve this equation, but do you really know what's happening behind the scenes? Do you know what it means when we look at the graph or when we look at a table or when we look at the equation itself? So this is where we're just kind of take a break, we're going to pause, and we're going to make sure that you're picking up on some of the deeper meanings of what we've been doing here. So let's see, we're going to do light blue today. So 6-67, the Alpine Music Club is going on its annual music trip. The members of the club are yodelers, and they like to play xylophones, of course. This year, they're taking their xylophones on a gondola to give a performance at the top of Mount Manche. That can't be real. The gondola conductor charges $2 for each yodeler and $1 for each xylophone. Okay, that's kind of important. So we've got $2 for yodelers, $1 for the xylophone people. It costs $40 for the entire club. So that's some kind of sum there. So it's going to be a total of $40, including xylophones to ride the gondola. Two yodelers can share a xylophone, so the number of yodelers on the gondola is twice the number of xylophones. Okay, that's important. Number of yodelers on the gondola is twice the number of xylophones. All right, so we're trying to figure out how many yodelers and how many xylophones are on the gondola. So we're going to represent this with a system of equations. We're going to start where you should always start. We're going to define what our variables are. So we're going to write these let statements. Looks like we got two things in here. We've got yodelers and we've got xylophones. So let's let y equal the number of yodelers. And we're going to let, I see what they did now. Let x and y see. I didn't notice that before. X equal the number of xylophones. All right, so those are going to be our two variables. And basically, that's what we're looking for. How many xylophones? And how many yodelers? So I want to find x and y in this one. All right, so now we're going to write an equation with two variables. Okay, so your equation needs to have two variables in it that represents the cost of riding the gondola. Let's go up here to where it was talking about costs. It looks like the cost of the whole club is $40, but there were two parts to that cost. It was $2 for a yodeler and $1 for a xylophone. So that's what it's going to cost to ride the gondola. So it's going to be 2 for every yodeler, so 2 times y, plus 1 times x, so $1 for the xylophones, and that's going to be a total of $40. So 2y represents the money that we spent on the yodelers, and 1x represents the amount of money that we're spending on the xylophones. Now, why are they charging more for the yodelers? The xylophone's going to take up more space. Moving on. Next, so there's one equation. We're writing a system, so we need two equations. Next, we're going to write an equation with two variables that represents the number of yodelers and xylophones. Okay, so this isn't the cost. This is just the number of each of those. So it says here the number of yodelers, we called that y, is equals, so y equals twice xylophones, so 2x. So there's my second equation. I've got this equation up here that's talking about the costs involved in getting these yodelers to the top of Mount Manche. So we got 2y plus 1x equals 40. So this amount here is the price we're paying for all of our yodelers, $2 times the number of yodelers, plus $1 times the amount of xylophones. So we're paying a total of $40. Now there's a lot of different answers that work for this one equation. I mean, if you think about it, I could have no yodelers and 40 xylophones. That would be possible. I could have 20 yodelers and no xylophones. That would be $40. So this one has an infinite number of solutions to it, because I can just keep on plugging in a number for y and getting a different number for x. And as long as they add up to 40, that's a solution of that equation. So there you go. Now my other equation has an infinite number of answers to it as well. So if I had 10 of the xylophones, that'd be 20 yodelers. If I had 500 xylophones, I'd have 1,000 yodelers. I've got a whole bunch of answers that work for this equation too. The whole point of a system is, where are we going to get an answer that works for both of the equations? And there can only be one answer in this particular problem for that. Okay, now we're going to solve the system of equation from those two equations. So we've got 2y plus 1x equals 40, and then I've got y equals 2x. Okay, so far we've learned two solving methods. We've learned how to do the equal values method, but that's where we had variables isolated on both sides of the equation. I've only got this variable isolated, and I don't have it isolated over here, so equal values probably not a great choice. So instead, we're going to use substitution. I know that y is equal to 2x. So what I can do is anytime I see y in the second equation, well, this equation says, hey, that's 2x. So I'm going to replace or substitute y with 2x. So this is going to give me 2, and then instead of y, 2x plus 1x equals 40. Here I've got 4x plus 1x equals 40. And here I got 5x equals 40. Divide by 5 and we get x is 80. 88. So what did I just solve for? X, the number of xylophones. It looks like there's 8 xylophones. Okay, so if there's 8 xylophones, this asks me how many yodelers and xylophones. So I've only got half my answer. There's 8 xylophones. Well, what I can do is I can use this equation right here to plug in. So I'm going to do y equals 2, and instead of x, I'm going to substitute 8. So I find out that there are 16 yodelers. So my final answer is there is going to be 8 xylophones and there's going to be 16 yodelers. I can double check my answer. I already know it works for this equation, but I can double check it by plugging it into this equation over here. So I do 2 times 16 plus 1 times 8, and I check to see if this is equal to 40. So here I got 32 plus 8. Yep, that's 40. So now I know it works because 40 equals 40. I am 100% sure that I got the right answer. As long as I made the equations correct, this is the solution to those two equations. It's the only combination of xylophones and yodelers that works for both of the two equations. All right, so what we're going to do now is we're going to use the graph from the resource page to graph our two equations that we made. What equations? These ones right here. So we're going to graph these on this resource page here called The Hills Are Alive. Okay, so here's my graph page here. Notice that they've only given us the first quadrant, and this makes sense because can I have a negative yodeler or a negative xylophone? No. So all of my solutions should be somewhere in the first quadrant. So I'm only dealing with the first quadrant here. Okay, our two equations, I'm going to just write it up here so we don't forget them. One of our equations was y, the yodelers, was equal to 2 times the xylophones. That was it, right? Yes. Our other one was 2y plus 1x is equal to 40. All right, so using purple, Okay, so using purple, I'm going to graph this first one here, y equals 2x. That's pretty simple. The slope is 2, and the y-intercept is 0. So that one's going to cross here, 0, 0, and then it's going to go up 2 over 1, up 2 over 1, up 2 over 1, and it's going to keep doing that forever. Do. Now, I am not going to connect these points. I'm going to leave it as a discrete line because it makes sense in the context of the problem to leave this line discrete. Now, think about, why am I doing this? Why am I not connecting all the points in the line? So there's all the points that could work in our equation, and I'm not going to connect them. The reason is, if I connect them, I'm saying it's okay to have some kind of fraction. And you know what? I can't have half a xylophone or half a person. Half a xylophone is silly, half a person is just gross. Okay, so this says only these answers work. So what are some of the answers that work? I can have in this equation no xylophone players and no yodelers, because this is going to be X, which is going to be our xylophones, and this is going to be Y, which is our yodelers. So according to that equation, remember this equation is keeping track of how many of each we can have. According to that equation, it's okay to have 0 yodelers and 0 xylophone players. And then the next thing it's okay to have is 1 xylophone player and 2 yodelers. Then I could have 2 xylophones and 4 yodelers, 3 xylophones and 6 yodelers, and so on and so forth. So those are all the combinations of xylophones and yodelers that it makes sense to have. All right, next one we're going to do in green. So in green, I'm going to do this equation. Remember, this equation models the cost that they're going to pay. That's 40, huh? This models the cost that they're going to pay to ride the gondola. Now, before I graph this one, I'm going to put it into slope-intercept form. So I'm going to subtract x first. So that gives me 2y equals negative x plus 40. And then I'm going to divide everything by 2. So that gives me y equals negative 1/2 x. I keep on putting 4. Plus 20. So I divided everything by 2. So this tells me that my slope is going to be 2. No, 1. I'm dying today. All right, my slope is negative 1/2. And my y-intercept is going to be 20 for this one. All right, so remember we're talking about xylophones and yodelers. So when it tells me the y-intercept is 20, it means something. This y-intercept means I can have 20 yodelers, but no xylophones, because that's the point 0, 20. And then it goes down 1 and over 2. That point means that I can have 19 yodelers and 2 xylophones. Down 1 over 2. This point says that I can have 18 yodelers and 4 xylophones. And we'll keep on going down 1 over 2. And this one's eventually going to keep on going until it hits the x-axis, and then I'm going to stop counting them because, again, we can't have negative amounts of yodelers or negative amounts of xylophones. So just like the previous one, we're going to leave this discrete. All right, so there's all the possible combinations of yodelers and xylophones. Now, look what happens down here. Over here, this point says it's okay to have 40 xylophones and 0 yodelers. This is, what, 38 xylophones and 1 yodeler? Okay, so there's all these points that work, and these are all the points that work for the equation that talks about how much we're paying for the gondola. There's only one time that this line and this line have the same exact equation, and that equation is right here. So let's look at the x value for that equation. This is 8. So the x value is 8. What's the y value? 16. 816 is the one place that these two linear equations cross each other. What do you know? 816. 8 xylophones, 16 yodelers. That's what we just solved for. So when we're solving these equations, what we're actually doing is solving for the graph of where the two lines cross. Remember, this is our x, which we're saying is xylophones. And this graph says I can have 8 xylophones and 16 yodelers. So the graph is just a pictorial representation of all that algebra that we were doing on the previous page. All right, what do you notice about your graph and your answer from part D? Well, we just noticed that the intersection on the graph was 816, and this is the answer we got in part D. All right, so we're seeing how those two connect to each other. Next, we want to name the x and y intercepts from your equation that represents the cost. Okay, so the cost, that was the green one over here. They want to know what are my intercepts, not intersect. They want to intercept. So here's one of my intercepts. One of my intercepts is at 0.20. That's the y-intercept. My other intercept is down here at 40, 0. Those are my two intercepts for the line that represents the amount of money that we're paying for the gondola. So our two intercepts are 0.20. That's the y-intercept. And then 40, 0. And that's the x-intercept. In context of the problem, what do they represent? Well, they represent 0 xylophones and 20 yodelers. So if there are 0 xylophones, there are 20 yodelers. All right, that's what 0.20 represents. What does 40.0 represent? 40.0 represents that if there are 40 xylophones, there will be 0 yodelers. How do I spell yodeler? Am I spelling it right? I don't care. And if there's 0 yodelers, how are they getting xylophones on the gondola in the first place? I don't know. Maybe they're powered. Whatever. Yeah, that works. All right. We want to name the x and y intercept that represents the number of yodelers and xylophones. That's y equals 2x. Well, the x and y intercept are the same. They're both 0. So 0, 0 is my x and y intercept down there. So the x and y intercept for that one would be 0, 0. It's the x-intercept and it's the y-intercept. In context of the problem, what does that represent? That means when there are 0 xylophones, there will be 0 yodelers. You might be asking yourself, well, how can there be 0 and 0 if they're going to be riding the gondola? Well, they can't. That's why that's not one of the solutions. 0, 0 works for this purple line here, but it doesn't work for the green line. That's why it's not one of our solutions. We need to find the one equation that works for both of them. All right, we're almost done. It doesn't look like it, but we are. All right. An intercept, which is what we were just doing, and an intersect are similar, but they're different. So what's the difference between an intercept and an intersect? All right, so an intercept, these are what we were just doing. This point, this point, this point. An intercept is when a line crosses the x-axis or the y-axis. So an intercept that's a line crossing the x or y-axis. An intersect, is there only one letter between those two? No, 2 letters. All right, intersect is when 2 lines cross each other. So that would be an intersect. So intersect two lines cross each other. All right, we're going to read the situation flow and decide if the graph would best be represented by an intercept or an intersect. And it says we don't actually have to solve these problems. We don't really have to graph them either. Okay, so here I've got a 5-gram candle on a birthday cake, and it's going to be lit. Okay, so the candle weighs 5 grams. Okay, that makes sense now. Okay, 2 minutes after it's lit, the candle weighs 4.2 grams. Okay, so we're losing weight from the candle because the wax is, okay, it's making sense. How long does the candle burn for? Okay, so when it says how long does the candle burn from, what are we really asking ourselves? Well, we're asking ourselves when it's going to stop burning when there's no more candle left. So that means when there are how many grams? 0 grams. So the candle stops burning at 0 grams. This must be an intercept because when we cross the axes, the x-axis or the y-axis, we have 0 as one of our coordinates. So this would be an intersect. Intercept. So if we were doing a chart here, we might start up here at 5 grams and then go down and burn, and we want to know how long. So this might be time over here, and this might be the grams over here. So this would be looking for the x-intercept. So that would be when there's 0 grams left. So how long when we have 0 grams? All right, next one says, a local bowling alley charges $4 to rent shoes and $3.50 for each game you play. Okay, so we're renting shoes and playing a game. Okay, another alley charges you $7 to rent shoes and $2 per game. Okay, how many games would you need to play in order for both alleys to charge the same amount? Okay, so games, that needs to be one of my variables. So games, so G equals games. And then, oh, charge the same amount, that's the cost. So we've got two different situations looking at the games and the cost. Now the cost is made up of two things. Cost is made up of the number of games, and then you have to rent shoes too. And you only rent shoes once. So for this first one, it would be 3.5 times the games plus the cost of the shoes. And then for the second situation, we'd have $2 per game plus $7 to rent the shoes. So really what we're looking for here is we got one starting at 4 and going a little bit steeper, and then the other one starting at $7, but it's not as expensive. So those are going to cross somewhere over here. This must be an intersect. So we're not looking where these zero out. So I'm not looking for zero games or zero cost. I just want to know when do these two situations show that they have the same cost. And remember, when we have intercepts, you want something to equal 0. And these aren't going to equal 0 because they're going to cross somewhere over there. All right, last one. 2 months after Aaliyah's birthday, she had $450, while her sister Claudia had $630. 5 months after her birthday, Aaliyah had $800, while Claudia had $920. How much did each person have on Aaliyah's birthday? Okay, so money needs to be one of these. So let's just make that M. What's the other variable? 5 months after. So that's time that's going by. 2 months goes away. Okay, so time is going to be our other one because time is going by. So if I was looking at this as a graph, time is always our independent quantity, and then we got money over here. So I've got two different situations. So 2 months later, we've got Aaliyah, and she's got $450. Let's just call this $450 right there. And 2 months later, she has $630. So Claudia has more. Okay, this one, green one's going to be Claudia. So Claudia's up there. 5 months later, okay, so that's 2 months, 3 months, 4 months, 5 months. Aaliyah has $800. Ooh, she's got more money. So she has $800 over here. And then Claudia has $920. So they're up there. How much did each person have on Aaliyah's birthday? Well, her birthday is way back over here. So it looks like we were looking for two things to cross, but we're not. Birthday would be over here. Because these are the months after the birthday. Here is the birthday. Our y-intercept is the birthday, because this is 1 month after, 2 months after. So here we're looking for where it crosses the y-axis. So that's an intercept. Tricky, tricky. All right, my friends, that's all we got. We were just going a little bit deeper into some of the stuff we're doing. Didn't really learn anything new today, but maybe you got a little bit of realization of why we're doing some of the things that we do, or what it means when we're graphing these, or what a solution means for these. I always get people like on the test going, well, what does it mean by asking for a solution? If you don't know what it means to ask for a solution, it means you didn't really understand anything we were doing. So get that deeper meaning in there. See you guys later. I got one more video to make, and then I can go home. See you guys later. Bye-bye.